So today we are going to start with some assignment or hands-on practice with the questions of plotting graphics here. So it includes 2D and 3D graphics both with some applications offered by the Matlab to use some plots or use some tools on graphics. So let us just start with plot a sine function by creating a vector of a value ranging from 0 to 2 pi using plot function and also by the plot tools. How we are going to do this? I'm going to take my script window here. One thing will be x is equals to 0 colon pi by 100. Let's say I'm taking pi by 100 and it will be till 2 pi. 2 pi I can write as pi in Matlab. And let's say y is equals to sine of x, and by using plot function we are using x comma y symbol. Okay, so it will ask me to save my file. I'm saving it by a1 name and it will just show me this thing. We haven't discussed the tools that we have in Matlab. We have Matlab tools like edit plot, zoom in, zoom out, pan, data cursor, brush, and many more things that you can use on your requirement. But usually we have this X level, Y level, title, legend, color bar, line, arrow, lighting. These are the properties of this plot tool, where you can change the values of all the plots and you can change all the values without writing the coding. We can use this plot tool for this. And in this question, one thing is new for us here, that is plot tools. What are plot tools? In Matlab, they are actually hidden plots. We need to open up them by using a function plot tools bracket make them on. Make them on because they are hidden tools. If you plot your 2D graphic or 3D graphic, whatever you want, you can then after that you can switch on your plot tools. And if you just notice here, we have a figure window on my another palette here. One window has been created. So if you want grid, first thing comes to me is grid, like x-axis grids, y-axis grids. We don't have z-axis because we are working in 2D graphics right now. So you can add z-axis grid also whenever you're working with the 3D graphics. We will put something in 3D graphics also. Right now we are in 2D. We have two axes, x and y, which are very similar to our workspace. These are my variables which are getting plotted here with 201 points, 201 points each. If you want a 3D graphic, you can create one more axis, and if you want to see this figure or include one more variable here to see what happens in a 3D graphics, you can add some more data to it. You can have image, you can have x-axis image shadowing here. See, this is in 3D. It should come in 3D. Why it is not coming? I don't want this because I am actually not working with the signal spectrums. So whenever you are working with signal spectrums, then you can see the intensity of your signal, how the frequency, and where the frequency was very large and very low. At that point, you can use these plot tools. You can use this line function to create line in between, arrow to point out something, double arrow to mention some distance, like from here to here you can mention the distance. Okay, and text arrow will have like text arrow. You can write something plain floor, whatever. It's up to you, whatever you want to write. I have written plain floor here. Text box, you can include your text box where you can write the Matlab graphics here. Okay, likewise, if you are mentioning something, you can use the rectangle. You can include something in rectangle, like this is your explanatory area. So where you are explaining something, you can mention rectangles or you can mention the ellipse. This is how the plot tool can help you to create much more interactive 2D graphics for you, and same as the 3D graphics also. If you want 2D or 3D accesses more and more, you can include them by pressing these things because they are new subplots. Subplots we have discussed in last lecture, last to last lecture, I think. So here we are just adding up them by clicking the buttons over here, like the 2D graphics have been added here. So it's up to you. You can change the layout. This is my layout. Let's say 4. I am using this kind of representation. You can choose them with this horizontal distribution also. So this belongs whenever you're working with the graphics and you want to show some particular areas with different angles and you're comparing different values in different axes, and this is just by the use of plot tools. Basically, they are creating subplots. They have the variables. They are including many things here on x-axis, y-axis, or if you want to change the font, it can help you a lot. You just need to put it on because it is a hidden plot. You need to show it up by pressing on button on it. So, okay, next question, which includes create area, stem, bar, pie, and stairs graph of the sine function. Okay, now we are going to create a sine function. I think we have already created this. We have already created this sine plot. We have this simple sine plot over here. We can mention many things with the plot tool also. We have discussed in last question, but in this question, what is my requirement is they're requiring to have area, stem, bar, pie, stair. Let me concentrate on area first. Okay, so I am taking area of x comma y. Run this thing. Okay, all the area under the curve till it is reaching to 0, it has been colored up with the area predefined function. Okay, next is stem, bar, and pie. Okay, let me take stem of x comma y, but I am opening up one new figure window here because it is already, we have already done with area in figure 1. So I'm just putting it off. This is stem. Stem is not getting cleared because I have taken too much numbers here. If I take only, let's say 30 numbers per pi. See, stem is like every marker, every bubble will have a stem till the 0. Okay. And okay, this was my second figure. Again, one more figure window, you can open it up. And next was bars, I think. Bar of x and y. These are the bars. Bar. Let me just reduce some bars over here. This is, let's say, 10. Yes, these bars, 10 bars per 10 stems, and area is the same. Okay, you can include figure to create new figure windows at every point. Here I want the pie. So I am creating one more figure window, figure pi of, let's say, x, because pi will include only one parameter. So here I am giving it as, this is a pie chart. We have discussed all the above here. So what I can do is I can comment them out because I don't want to see them again and again. I'm just commenting my things up here. So last thing is, which is going to be executed here, is pie. This is my pie chart. This is how you can use it. And last was stairs. Okay, we will include stairs also. Figure stairs of x comma y. Only pi will take only one parameter, but stair will take like two of them, like x and y, say. So everything will look like a staircase. These are the different methods how you can plot your sine wave in 2D graphic. It is your presentation idea, how you want to explain your presentations. Matlab will help you out there. All right, so this was my second question. Let us just move to the third question. Using the same figure as in question number 1, name the axis and put a title in the figure window by the tool provided in the figure window as well as by using the functions. I think we have done with the functions. We have already done with the functions. I'm removing this, not all of it. I'm removing this thing. Okay. So by using functions, we have already done label. X label is, let's say, time. Y label is sine. And title is sine wave or whatever you want to write. It is just a string. It will get show up at its places. Okay, title spelling is wrong here. Title means E in the end. And if you see here, sine wave, time, and sine. Okay, if you want to include some text over here, we have one more option in, although it is not asked in the question, but I'm telling you that we have one more text filling option, that is G text. Okay, and whatever you want to write, like you want to write V1 multiplied by sine theta. It is your, let's say it's your equation and you want to write it like this inside your figure window. But G text will help you to write wherever you want. It will get you a cursor and you just click on it. It will give you wherever you want to click. Like this is my G text. Where you want to click and put the value. Let's say at this point. Click it and your text is here. Okay. Test text is incomplete this time. Bracket was not here, so if I want to write like here, G-text will help you to put your text without any particular value where you want to put it. It will give you a cursor. Just click on it and your text will get printed on the figure window. Okay. This was like one more example. I want to give you legend. I don't know, maybe this thing will come up in later questions. Legend, I want to write like X data. This is my X data. Okay, or like this. Legend. So it's G text, and see, this is my legend. X data. You can even edit it from here. It is not X data, it is my sine wave. Okay, let us say this is my sine wave. So this is your legend. Legend means you are mentioning that this graph belongs to this category. Okay, you can put grid on, grid on. By default, grid is off. Write your G text wherever you want, and you'll get the grid after using this grid on. Okay, so this is how you can do these things with the functions, but the question was asking to do all these things with the help of the tools also. We have some tools here like insert X level. X level will like give you some uh, X axis, right? I am writing X axis. And if you want to insert something on Y axis, it is my Y axis